Hello students, I am Saurabh Bhadra, your TA of the course Introduction to Classical Mechanics PH 28. Today we will learn a powerful tool, that is Mathematica, as a week 0 assignment of your course. So Mathematica is a very powerful computational tool that helps to solve various equations, and it can do much more that we will take a look. Now the basic version of the Mathematica is free. You can search Wolfram Cloud in Google and you can make an account in that. As you see, I have already made an account and I will click on the new notebook. It is taking some time, so it will open. So it is the here you can write your Mathematica code. Now to check, let us add two number 5 plus 4. You know the answer is obvious, it is 9. So to run this code you have to enter the shift plus enter key. So shift plus enter, the output is 9. So it is working. Now we will solve some simple examples to get an idea about the Mathematica. So first we will try to find some roots of some algebraic equations. Okay, let's do that. Now the title, how to find roots. Alright. Okay. Now the command will be solve, that is this. So for every Mathematica command, the first letter of the command will be in capital. So S must be in capital and all other in small. Then you need to include a third bracket and close the third bracket. The expression for which we want to find the roots will be in this third bracket. So let the expression is 3x cube plus 2x square plus x plus 2 equals to 0. And to put a equal sign in Mathematica, you need to enter 2 equal. So that is like this, equals to 0. And we also give the information that it is this expression, in this expression the variable is actually x. So how to do that? You put a comma and write x. So Mathematica will understand that this is a x is a variable in this expression. Now enter the shift plus enter key. So it will give you the solutions. So as the power of the equation was 3, there must be 3 solutions, and these are the 3 solutions. And if you want the numerical solutions of this equation, that is the numerical value, so instead of solve you have to put the n solve. So if you put n solve, the solution will look like this. So this is these solutions are same as the previous, but the numerical values are shown here. So it is the way to find roots of various different equations. So let us take another example. Another expression, that is x cube plus x square. Let us take 2x square plus 2x plus 1 plus 2x plus 1 equals to 0, and the variable is x. Now the answer will be this. So this is the procedure to find roots. Now we will do some plots. Okay, so some plots. So what we should do to make some plots? The command will be plot with a capital P, then the third bracket. Now inside the third bracket, the expression which you want to plot, that must be written in the second bracket. like say I want to plot x square. So the x square will be in the second bracket, and we have to define the range of x. Suppose I need the x square plot in the range of 0 to 50. So x starting from 0 to 50. So this is the way to define the range, which is the x range, comma, the initial point, comma, the end point. Now if you enter the shift enter key, you will get the plot. You can see the plot. This is a very easy way to plot some functions. Now let us plot the log function. So this is the same thing, plot, third bracket. Now you have to write the expression which you want to plot in the second bracket, as I told you, that is log, and the variable is x, close the second bracket, comma, the range, suppose it is also 0 to 50, close the second bracket and shift enter. So you will get the plot of log x also. Now now next we will do the plotting of multiple function in a single plot. Okay, so plotting multiple functions together. Now how to do that? In this case, the command will be same as plot, but the multiple functions which we want to plot, that must be given as a list. So how to do that? I will show you that. First you need to give a curly second bracket, then you have to enter the multiple functions you want to plot. That is, that I want to plot 3 functions. One is 1 by r, okay, comma, the second one is 1 by r square, comma, and the third one is minus 1 by r plus 1 by r square, 1 by r square. So these 3 functions I want to plot in a single axis, that is 1 by r, 1 by r square, and minus 1 by r plus 1 by r square. So this is the list of the 3 plots I want, and similarly comma, and we have to define the range of the axis. That is, let us say r is from minus 5 to 5. Okay, now shift enter. Yeah, this is the result. So you can see there are multiple plots in a single figure. Now the question is, which plot corresponds to which expression? It is not clear. Now to get the legend, we need to add a legend command, okay, that I will show you. Okay, so this is the same as previous. Now what you have to add is this one, plot legends. So it is also a command. So p will be capital, plot legends, l of the legends will also be capital, legends, then a arrow, then a arrow, then a arrow, then under comma you have to write expression with a capital E, expressions, then shift enter. Okay, so I have made some mistake, the P is not here. Okay, now it will show. Yeah, so you can see here it is clear which color corresponds to which function. Like this blue is for 1 by r, this yellow is for 1 by r square, and this green is for minus 1 by r plus 1 by r square. So it is clear from this figure. So this is the way to do multiple plots in a single figure. I think it is clear to you. the main difference between the single plot and the multiple plot is for the single plot the function will be only one, and for the multiple plot the function will be a list divided by these commas, separated by these commas. Now let us try some trigonometric plots. Okay. Now we will use this multiple plot method in this trigonometric plot. Okay. Let us try to plot sine x, sine 2x and cos 3x in a single plot. So how to do that? So plot, then we have to define a list with these three different trigonometric function. Sine, the first letter of sine s will be capital, sine x, comma, sine 2x, comma, cos 3x. First letter of every sine cos is capital, you can see. Then we have to define the range as previous, that is, let us define x from 0 to 2 pi, close the bracket. And we also want the legends, so plot legends, arrow, expressions. Okay, let us see. Yeah, so you can see the different plots here, and it is quite obvious. It is obvious that this blue is the sine x curve, and this yellow is the sine 2x, and this green is the sine x. So, and you can see the nodes also. For the blue curve, for the sine x curve, the nodes will be at pi, but for the sine 2x curve, the first node will be at pi by 2. So it is obvious from this plot also, right? Yeah. Oh, now these are the different trigonometric plots we have done. Now we will go into another thing, that is the polar plot. Okay, so polar plot. Okay. So let us plot polar plot means the r and theta axis. So let us plot r is equals to 2. So we will plot r is equals to 2 at first. R is equals to 2. That means it will give you a circle for all theta values. Now how to do that? So at first we have to define a variable a equals to 2, and for defining a variable we must end it with a semicolon. Now the command will be polar plot with this p and this p capital, third bracket. Now you have to give the expression a, comma, and the range of theta. So how to write the theta? It is escape theta escape. Okay, and let theta starts from 0 to 2 pi, and close the bracket. So it must give us a circle with radius of 2 unit. Yeah, so you can see it is giving us a circle with a radius of 2 unit. Now we will do multiple plot, polar plot with this circle and another functions. Now this was the previous case. Now as I am doing the multiple thing, we must retain the functions in a list. So a was the previous thing. Now let us include the sine theta also. So escape theta escape, third bracket close. So it will be a multiple clause, that's why it will be better to add the legends, plot legends, this one, the arrow and the expressions. Okay, yeah, so you can see this was the previous plot and this is the sine theta plot in the polar axis, where is the r and theta. Okay, this is the way to make the polar plot. Now we will do another thing. We will plot some ellipse with different eccentricity in a particular axis, a particular figure. Now okay, so for let us write that as a title. So ellipse, so it will be good if we can write, we can do some other thing. Some problem is maybe okay. Ellipse plot. Okay, now let us do that. Sorry, there was some problem in my machine. Okay, now we can do it. So all you know that ellipse, the equation of ellipse will be like that, one that is like 1, I mean not 1, p by 1 plus e cos theta, right? Theta. So this is the equation of a ellipse generally. So now we will plot different ellipse with different eccentricity, that is the e value, in a single plot. Now let us do that. So for this we need to define a function. Now how to define a function in Mathematica? So f, it is the way of defining a function. In the third bracket we have to write the variables of the functions. That is, for our case the variables are this theta and this e or epsilon, whatever you can say. So it will be a function of theta and e. Now theta, theta, and you need to give a underscore when you are defining a function, comma e underscore. So remember this particular point, this underscore is very much important when you are defining a function. Now a colon equals to, all these symbols are very much important, this colon and equals to. Let us take the p as 1 and 1 plus e, the cos, c of cos will be in capital, and the theta. Alright, close the bracket. So this is the function of theta and e. Now in the same way we will do the polar plot, third bracket. We have to define a list. Now we will plot for 4 different values of e that we will write in our functions, like f theta escape, theta escape. Now here you don't have to include that underscore. The underscore is needed only when you are defining the function. So f theta comma 0.4, that means for first plot I am taking the e as 0.4. Okay, now in the same way, comma, for the second, the theta will be 0.8. For the third plot, the theta will be 0.9, and for the final plot, the theta will be 0.95. So these are the 4 plots I want to make in a single figure with the range of theta from 0 to 2 pi, and plot legends expressions. Okay, now enter, shift enter. Yeah, so this is the plot. This is the different ellipse with different eccentricity. The blue one is for 0.4, the yellow one is 0.8, the green one is 0.9, and the red one is 0.95. And as you can see, with increasing eccentricity, the shape of the ellipse is changing. So this is a way to this is the way to plot the ellipse, and the main purpose of doing this particular thing is to show you how to use the function in the plot. So here we have defined the particular functions, and we have called that function when we wanted to plot that. So this is the way. Now another way of defining a function is this. I will just copy it to show you that in the previous case we have put the semicolon and equals to to define this particular function. Now one thing you can also do when you are trying to define a function, you can, instead of giving a colon here, you can do the semicolon at the last. So okay, by mistake I have done it here, no problem. So yeah, here it will be good to do it. Okay, so instead of that colon, we can put the semicolon at the last of the function. That will also work. Okay, so there is these two different way to define a function. Colon equals to, either colon equals to, or the equals to is here and the semicolon is at the last. Okay, then both will give you the same result. Yes, now we will do some parametric plot. So parametric plot, like x equals to sine t, y equals to cos t, where t is the parameter. So this is called the parametric plot. Okay, now how to do that? So for this, the command is parametric plot. You can see here also. If you want to plot in 3D, then parametric plot 3D command is also here, but we will only do it in 2D. So parametric plot. Now the third bracket, then again we need to define the functions sine t, comma cos t, end of the bracket, then the range of t, that is, let's say 0 to 4 pi. Yeah, this one. Shift enter. I have made something wrong. Okay, this is the third bracket. Yes, so you can see this is the plot of x equals to sine t, y equals to cos t, and it is obvious that this is the equation of a circle, so it is coming out to be a circle. Now if we change it a little bit, now we will change it like x equals to sine 2t and cos equals to and the y equals to cos t. Now it should not be a circle, right? Let's see what it comes out to be. Yeah, you can see it is not a circle, the shape has been changed. So this is the way to do the parametric plot. You can try many different things that you can play around with the code. Okay, now we will do some other thing which is very important but very easy to do in Mathematica, that is the differentiation. Okay. So here also we need to define, at first we need to define the functions which we want to differentiate. Okay, now let us define the function. So suppose the function is x square. Suppose the function is fx is equals to, oh, what happened? Yeah, fx, it is a function of x, and as I am defining a function, the underscore will be there. Then you can do whatever you want within the two methods, that is colon equals to or the semicolon at the last. Let the function is x square plus 2x. Okay, now to differentiate this particular function, we need to enter just this command, f dash of x, and it is done. You can see how easy is this. Now this is the differentiation of x square plus 2x, that is 2 plus 2x. Yeah, it is clear. Now let us take another very easy example. Fx is equals to x square plus x. I will just ask you to play around this course and do some interesting differentiation of some interesting expressions. These are very simplest. Alright. So this is the differentiation. Now we will do some matrix thing, which is very important in physics as well as mathematics. Okay, now let our matrix is, we need, at first we need to include the elements of a matrix. So I will show you the matrix which I want to do. Just a second. Yeah, so this I want to solve 1 1 0 1 0 1 and 0 1 1. Okay, now let us do it. 1 1 0 1 0 1 0 1 1. Okay, now second bracket, then we will include the elements row wise. 1 1 0 1 0 1 0 1 1. Okay, so this is the matrix. This is our matrix. Now we need to find the eigenvalues of this particular matrix. The command is eigenvalues with a capital E of this particular matrix. So you can see this is the these are the eigenvalues. Now eigenvectors. Okay, so eigenvectors are this. Now we can also diagonalize the matrix. To diagonalize, we need to inverse this P matrix which is made of the eigenvectors of this particular A matrix. So how to inverse the P? Let us define a variable inv of P, and the command is just inverse. So this is the command, inverse, and give the matrix, that is small p. Okay, so this is the inverse of this particular matrix. Now to diagonalize the matrix A, we need to do P dot A dot P inverse, right? That is inv of P, and shift enter. Yeah, so this is the diagonalization of the matrix, and you can see this, there are only diagonal elements present, that is 2, -1 and 1, and these 2, -1 and 1 are exactly the eigenvalues of this particular matrix A. So it is clear that we have done the diagonalization in a correct way, and the diagonalization is correct in this mathematical scheme. Okay, now another last thing we will do today, that is the differential equation with boundary condition. Okay, now for this we will solve this particular equation. This particular equation, y dashed plus y is equals to a sin x, where the boundary condition is y at 0 is equals to 0. Now if we want to keep that y dashed in the left hand side and all other in the right hand side, then the equation will look like y dashed is equals to a sin x minus y. So we will define our equation in Mathematica in this way. Our equation in Mathematica will be y dashed is equals to a sin x minus y. Okay, now let us do that. Now our equation will be y dashed, and it is a function of x is equals to a sin x minus y. Now let us take the a as 1. So sin x minus y is also a function of x. So it is very important to write the variable in the argument of y, that y is a function of x. So this is our equations. We need to solve this with that particular boundary condition. Now at first, suppose we don't have any boundary conditions. Now what will we do? Now the command is d solve. D is capital, S is capital, D solve, and this whole equation will be inside this bracket. Here we have to define that here the y is a function of x and x is a variable of this equation. So in this way we have to define. If you now enter the shift enter, I have made something wrong. Okay, as I told you, not a single equal sign, there will be multiple equal sign. What is happening? Let me check. Minus yx let me try it again. D solve third bracket y dashed x is equals minus y x plus sin x x comma y, which is a function of x, and x is the variable. there is something wrong. Let me check it. Dissolve. Okay, I will check it later. Let me check my files. There is, I have done it already in the previous case, so I will show that. Yeah, here you can see, I don't know what is happening in that particular file. Here I have written that dissolve y dash x is equals to minus y plus sine x. Here here it is also giving me some problem. I don't know why this is happening. So I will check it later and I will tell you what the problem is. So for the first tutorial, I will for the first tutorial, this was the material which I want to cover. I don't know what happened in the last thing. Actually, I am also learning the Mathematica with you people. I have not used it earlier, so I will take a look and get back to you. So I will stop here for today. Thank you.